Okay, hello. This is JF Brandon from BotFactory. I'm not sure who's on the other side. I got Troy here and an SV2, and we're going to do a little demo just to run through how we can print with SV2 and save time and money. Please let me know if you can't hear me, and we'll be able to sort of remedy it. So let me just test the. Is everything all good? Yep. All right. Is anyone commenting, saying anything? Okay, cool. So I'm just going to go through the whole process. As you can see, the right below is our interface, and to the right is the actual machine, right next to me. We're going to be printing a pretty straightforward design. Just do a single layer so we can run onto the dispensing and pick and place functionalities, and we can hopefully get this all done within 45 minutes or so. Please let me know on the live chat if you can't hear me or if you can't see anything. We will do our best to remedy the problem as we go along. Okay, so I have with me a few components, some resistors, just some straightforward stuff, and I'm going to print a single layer. We're going to print something we've actually printed before, right here. Okay, so if you look at the interface, which I'm just going to enlarge right now, give me 1 second. If you look at the interface right here, this is what you see when you connect to the machine. Pull it out of the box, set it up, connect to the device. There's lots of ways of connecting, and if you go to our support at BotFactory, you can request some information there. Also, if you go to our website and click on support, there's a tutorial on how to connect. Typically, this is where people may have issues because we connect by browser. Why do we use a browser? Excellent question. It's really easy for us to make our machine work for any sort of device, Linux, Mac, PC, and it also makes it easier for us to actually upgrade your machine. We're constantly changing how printing algorithms work, how dispensing, how pick and place works. It's just easier for you if the machine gets upgraded. We do have people who have security arrangements where they can't necessarily connect the machine to the internet. That's fine. You can always get a dongle, download it from us, and then plug it into your machine, and then you can basically upgrade your software that way. As you've seen before, our machine has 3 different heads. Let me just switch over to the video again so I can just sort of explain what we're going to be doing. So we have 3 different heads. This is the pick and place head with the pick and place tips here. We have the print head right here, which is going to have 2 types of cartridges. We have a conductive ink cartridge and a insulating ink cartridge. That prints the polymers as well. And these are the two materials that you need to actually basically print a multi-layer board like this. By the way, if you haven't seen, we have more content and material that we can share with you. Just ask Troy or me, and we can send you some more information, some more video, and some more pictures of the material we have. This is the dispensing head, and this is how you actually dispense the material onto the pad so you can pick and place the components on. And all of these heads are essentially swappable on the machine. That's the whole idea. We want to make a future-proof platform that allows you to not only print but also dispense and assemble, and perhaps more heads in the future. Or if we come up with better printing heads, we can actually improve your experience and your inkjetting capabilities. We actually went from single layer printing on paper with our first product, Squink, and we moved on to actually printing multi-layer on other materials by upgrading the inks and upgrading the actual heads, but they were interoperable with the existing platform. That's kind of our whole vision here. So going back to the software, I'm going to show you how to upload a video or upload a file. So our machine works off standard Gerber files. These are the sort of standard type of design files that you may see if you work with PCB manufacturers. Every single electronic design application and electronic PCB CAD tool, PCB layout tool exports Gerbers. And in order, you want a Gerber, the latest type of format, which I think is RS274X. You also want to export the drill files and the paste file and something called a centroid rotation design. But going from there, if you're doing a single layer, you only need to upload the sort of one of the layer files, and that's it. So when we start off, we click on Start New Print. And if we're doing a single layer design, what we can do is we'll upload the various files. The first type of file I need is something called an outline file. An outline file is also known as a mechanical details file. Mechanical details file is just to find like the edges of the design. If I don't have the edges of the design, I don't know necessarily where the edges are going to be. So if I'm printing something that has like a design edge designed that's smaller than the traces, then lots of it's going to cut off. It defines the actual virtual edges. You can upload like a mask file, or a silkscreen file, anything that's larger than your traces or your paste or your pick and place files. In your design, you want to actually place everything more or less to the top right of the origin. So your origin is going to be in the bottom left. Just give me a second here. You should find the file. Okay, medicine. Single layer. Here we are. Okay. All right. So. .gts. Here we go. Okay. So I only have the. You can also, if you don't have the outline file and you're doing a single layer, you can just upload the single layer trace file basically twice. It's the largest in terms of area file, so you can always use that. Actually, this design does have the edge cuts. If you use KiCad, if you're familiar with KiCad, you can export KiCad files, which are typically called, they have their own file namers. We use KiCad in all our designs, so it's also interoperable with KiCad, also known as KiCad, depends on how you learn how to call it. We have paste file, which is our glue file, and that defines the sort of places, the pads we're going to be dispensing upon, and the pick and place, which is the .pos, .csv. It's essentially a file with series of headers and the information regarding the x, y coordinates, and so forth. We're going to go through that very shortly because once we've uploaded the files, SV2 is going to ask us for a bunch of different questions about how to do everything. About basically how to essentially interpret what you've given it. Curing profiles. So depending on what kind of substrate you're using, you want to use a high temperature substrate like an FR4 or Kapton. You just use a standard cure profile. What I'm talking about here is we're inkjetting conductive inks and we thermally cure it. So in order to thermally cure it, we have a heat bed underneath that we've taped down the substrate to. Some materials like PET you can print on, but they can get warped by the high temperature. So we also have a low temperature cure profile as well. And you can also do no curing where you just print, it stops, take it off the substrate, and you cure it. And that's fine because we'll have to re-register it later, but there's actually a process with allowing you to re-register designs. If you take them off, cure them in your own other way, or treat them in another way, and then put them back on the machine. All the processing happens on the machine, on the back end of it. Nothing is sent on over the internet or anything like that, despite this being an internet-connected device. I'm connected to the internet, but if I wasn't, it would still operate. Everything's being processed on the machine. At this stage, it's kind of WYSIWYG, so it's going to show you what you see is what you get. And you're going to be able to see at least the different parts of the machine, the design rather, aligned with different parts. Coloration is kind of indistinct, but you can see that everything's aligned properly, which is good. We want to make sure that everything's aligned so that the machine can basically self-register itself if you choose to. You don't remove the board or anything like that. Okay, so remember when I said about uploading a pick and place file? When you upload a pick and place file, you need to actually tell what headers mean to the machine. So certain CAD tools define, the designator, the name of the actual component as ref. In this case, ref. But I need to actually tell the machine what ref means. It means the designator, in other words. Value, I think it just means basically a comment. And if you have information that you don't know where to send anywhere, like information regarding like the size of the component or information regarding the, let's say, value in terms of its electrical capabilities, or note like, it's the blue capacitor, not the red one, you can put that in comment. Package means footprint, obviously. Position X means X. Position Y means Y. Rotation, rot. Comment. Side, obviously I'm printing on one side, so I'm just going to send that to comment. You can also click on ignore if you'd like. Click next. Next step is really interesting. So every single component here has a particular size, and I need to actually know what the exact size of it is depending on the dimensions provided by the data sheet. So for example, I have a bunch of SOIC chips. SOIC chips are essentially, in this case it's an AT Tiny. I need to actually get the dimensions of it and place it and put that information in here. Why is this important? The machine doesn't understand what the size of a component is. It knows what a footprint may be, like an SOIC 14, but different companies call it SOIC 14. They may have slight differences on dimensions. 1206s, for example, are typically always the same, but it might be slightly different, and it can throw off the machine a little bit. In this case, I'm using components I've used before. I know how big they are. These SOIC, or these 1206s are 3.2 millimeters by 1.6 millimeters. And it's basically using the information in the zero rotation in your CAD tool. So if you know what a footprint editor is as part of your CAD tool, you have to provide the information as it would be defined in your footprint editor as the zero rotation. Some people get confused about why the components aren't oriented correctly. We use all the information that you give us in the CAD tool from its zero rotation in the footprint editor. This seems a little difficult and a bit of a steep learning curve for some users. I understand that. Believe us, pick and placing is probably one of the more difficult things to do in electrical engineering, electrical production. And for some people, it's really surprising that a lot of effort is done by the companies that do assembly, and that's why assembly is so expensive. 70% of the costs of PCBs is in the assembly, because every component is slightly different. This machine makes it easier because you at least know a little bit more about the process. You can validate your assembly process so that when you send it out, you can be like to your assembly house, hey, this works. I've done it, tested it the same way, it should work fine, it should work for you. So I put that information in, SV2 calculates it, re-uploads, and then reflashes the information that you put in. So that size seems correct. Let's put it in here. 3.2, 1.6, oops, 6, 3.2. So you see here, these are the resistors, so they're all being placed here. Click save, so on and so forth. Any comments from anyone? Okay, cool. Yeah, by the way, please let me know if you can't hear anything or if you have any questions, and we'll respond right here. These are components I don't have and I don't intend to place, so I'm just going to put random values. I can't move until I go to the next step, so if you have components you don't want to pick and place with the machine, just insert whatever valuations you want. Like this component is a giant coin cell battery thing that actually I never even place with the machine, it's just too large. And this is an interesting question. I cannot remember what the actual size of the SOIC package is. So I'm just going to look this up. Dimensions sheet, 1 second please. Okay. Dimensions of an SOIC. It is 3.9 by 8.6. Okay. 3.9. Ooh, that's not bad. No, that's not correct at all. Actually, this is not an SOIC 14, is it? It's an SOIC 24.
20.
Is it 20? Oh, is that what it says? It does say so. My mistake. I put the wrong number in. It's an SOIC 20, which is dimensions are, and my computer is moving at a very slow rate. Should have brought calipers with me. 12.8. Okay, 12.8 by 2. 12.8 by 7. Okay. Go save footprint. When I'm using components like an SOIC or anything else that's close to square, we like to go with the most extreme aspect ratio. It makes it easier to pick in place. It's a small little tip. So, for example, this SOIC chip, you can't see it with me, but if I gave the full dimensions, it'd be 14.5 or 12.5 by 10. That's with the leads. I actually excluded leads and provided the package size, excluding leads, because I got a higher aspect ratio. Getting a higher aspect ratio allows me some information, allows the machine to kind of better understand what direction it's actually, what orientation it's going to be placing the component. That's just a little trick I find to be pretty useful to know about. But it wouldn't be necessarily obvious to a user. We're thinking about more of these videos and maybe making very specific videos and hints and tips. Let us know if you're interested in doing that, because we're thinking about integrating that maybe in with the machine. Provide like a video you can just click on, and we can provide like a 5-minute video for each step of the process. Ideas like this are really what we're trying to make is an easier process for you, so that when you use the machine, you kind of learn how to use it, and then from then on, you can move on. Okay, so clicking next. Okay, attach the board. Okay, so let's move to, I don't think you can see the video, but I've already pre-attached the board, but placing the board, we usually use tape. Why tape? Works for every kind of size. Capped on tape works really well, and I find that actually, in this case, just an inexpensive and easy to use solution.
You have a question?
Sure.
If you're going to populate the board yourself, can you skip all of the pick-and-place stuff? Or will the software make you go through those steps regardless?
That's a great question. It only asked me all those steps because I uploaded pick-and-place files. I didn't have to. I could have uploaded just the print trace files, and it would have just gone to printing, and that's it. If I'd uploaded the paste file, and that's it, it would have just gone to the paste and dispensed whatever you uploaded. If you went to just pick-and-place, it will just do pick-and-place and skip everything else. Does that answer your question? Okay, click next. Okay, yeah. Sorry about the delay. Okay, so let's just move on. Okay, so I've pre-made a little cartridge here. And I think I'm just going to go to the video very shortly so I can demonstrate to people how to clean a cartridge before using it. This gets a lot of people, it's a little annoying. Printing process requires a little bit of care and thought, and I'm just going to quickly go through that right now. So, we have here a cartridge that's fresh out of the box, and we have our lovely lint-free Kimtech wipes, and a BotFactory provided deionized water syringe. Yes, we do provide MSDS sheets for deionized water. Someone asked this one time. What I find is that after you remove the clip, it's a good idea, even before starting printing, typically there's a little bit of dried ink on there. You'll see some silvery ink on there. Just take some water, drop a few droplets on there. If it's clogged, it's okay. The water eventually just breaks out the material, the semi-cured ink. And then what I do is I take a piece of folded syringe, and I basically put it up against a table or sort of surface, horizontal surface, and just like let it sit there for about 5-10 seconds. And what you're going to see is a lot of black ink coming out. There's a cleaning system with SV2, unlike Squink, which is super valuable for reliability sakes. But this process just gets the whole system jump started. It really kind of helps the ink flow through. Okay, so moving back to the software, lock the cartridge, and then let's go back to the video so you can see. Actually, I'll do that. Click next. Please attach print head. Drop in like that. The machine will look at the head, calculate if it's at the right version. If it's updated to the latest firmware, it's going to upgrade the head as well to a later firmware. I'm just going to do one repetition because we don't have a lot of time. For a couple of tricks here. One trick, the more repetitions you do, the more likely the ink will flow out. It will actually move away and migrate. It's called migration. There's lots of great papers written on ink migration. And there's a couple things you can do. You can increase the print temperature on here to 50 to 55 or 60. That allows you sort of a chance for the ink to cure a little bit more to the substrate before too much ink comes and starts migrating and moving away. If you're trying to print really thin traces and you're having trouble, the best bet is to raise your temperature to as high as you can get it and do one repetition, cure it, and then click print again afterwards, and basically will print and then cure, because there's a curing process afterwards. It takes longer, but your prints are going to be much more better in terms of connectivity, in terms of continuity, and in terms of like aspect ratio, in terms of like the quality of the print. Those are a couple of tricks we found that work really well. After a print, you typically do a few tests of traces. If you don't like continuity, you just do one more pass. So for this sake, I'm just going to do 50. I find that the lower the temperature, the more the inkjets jet, because heat can cause curing in the print head. Okay. All right, everything's ready. So we click Start Print. And we'll watch the machine print. I'm just going to put this to the front. Does anyone have any questions, by the way? Before the machine completely drowns me out.
Question. You guys are working on an enclosure to bring the noise down.
That's a great question. I'm not sure if you can hear me because the machine's printing right now. But yes, we are working on an enclosure right now to reduce the noise. The way we are doing that is, we're literally designing one right now. I'm not sure when it will be ready. So far, printing really nicely. Oh yeah, that's beautiful. Can you see my text? Okay. All right, so I'm just doing some housekeeping right now, reading what Jared wrote here. I I just want to comment on the printing and how printing works while we're watching this print go down. The process is pretty straightforward. In the past, I would say 5-10 years, nanoparticle silver has become a relatively well-known way of actually a relatively easy thing to make now. We're talking particles of nanosilver that are in the range of 10 to 100 nanometers, which is hundreds of silver atoms across. So there's countless number of these particles in our ink, and we're inkjetting them onto the surface. Unlike normal bulk silver, like think of silver rings or cutlery, you need to melt it. You need to melt it at thousands of degrees Celsius. But when you have the particle size that small, you can actually melt it and turn it into pure bulk silver at temperatures ranging from 70 to 150 degrees Celsius. So what we're doing right now is we're inkjetting it onto a surface at around 50, 60 Celsius, enough to kind of get it to start curing, so it stays on there, fixes on there, pins onto the substrate, and then we inkjet print more and more, stop it, and then thermally cure it, driving off any of the extra fluids in there and leaving a pure layer of silver behind.
Question: what's the gap distance between head and print material?
That's a great question. I would say, looking at it right now, I would say it's around 5 millimeters. We've tried to get it as close as possible without hitting the substrate. Does that answer your question?
Do you use a feeler gauge or other calibration device?
Yeah, actually. So there's a lot of really interesting hardware inside that head holder. You see at the top of the video, that black part that holds the print head has a fairly complex sensor system because it's all magnetically connected that essentially senses ever so slightly the feedback it gets from just touching the surface, and that's really important for dispensing and pick and place later. But long story short, yes, there's a very complicated way of testing the surface, and then we print from there. But we'd only do it once for inkjetting. We don't map out the surface in any way to get it closer and deal with the sort of curves and rolls of a sort of bumpy or non-smooth, non-flat substrate. By the way, can you still hear me over the noise of the video? Just to be sure. Just let me know if you can't hear me. I'm not sure if you've seen this on our website, but the specs in terms of inkjet printing are 8 and 8. Always make your traces as thick as you think you can make them, because the conductivity is not equal to that of copper. Although the silver material itself is more conductive than copper, we're printing very thin layers. To give you an example, I believe your standard 1/2 ounce or 2 ounce copper is, I believe, in the range of 1.5 mils. Ours is in the range of like 0.1. 2 questions. Unlike the Gen 1 Squink, no manual distance or offset process. Actually, Squink has a similar sort of process for, essentially analyzing where the surface is and then jetting it. You can't manually change how high or low it goes. We get it basically as close as we can get it to the surface. But, if you really want, you can always just move the motor up if you want it higher off the surface. By the way, like if you make a thick substrate, let's say you print on a really thick piece of substrate, the machine will just hit that and print above it. It doesn't matter how thick or thin your material is. It's always going to go to the highest, as close as it can to the substrate. It just can't do non-flat material, that's all. Fashion house, are we limited on what type of material we can print on? Great question. So I can print on FR4, Kapton. We've printed on things like acrylic, PET. We know customers have tried paper. I've printed on glass. I had really good results with printing on glass. I also found that it was really good to solder to too. It really the ink just sticks on there like craziness. Can you control how much self-cleaning and clearing the head does in the waste area? Good question. You can't. And the reason why is not only are we cleaning and clearing out the ink in there, we're also cooling the head down by doing so. Basically, it's jetting in a very hot area, and we're just on the edge where it starts to cure. So there's sensors in there, temperature sensors along the ink channels. And if we hit a certain value, we actually automatically return the head to the cleaning station and clean it out. There's a couple of things you can do, though. You can reduce the temperature at which you inkjet at. You could put it down to 40 or 30, and that might help you out in terms of how many times it goes back. How many layers is this board? The design I'm doing right now is just a single layer board, but we've done 4 layers. Now I could have actually done something, I could have printed a mask as well, which is pretty cool. You can also print masks. Basically what you do is instead of uploading a drill file, you upload your paste file or your mask file, and it will print everything except for where you essentially defined areas that you don't want it to print. Just going to take a look. We're going to be done here in about should be done curing in about, should be done printing in 1 minute, and we're going to be curing for about 10 minutes. So it's a good time to ask questions. Is 4 layers a template, or do you have to do multiple runs with isolation in between them? Is 4 layers a template, or do you have to do multiple runs with isolation between them? Yes. In order, so the way you make boards today is I'm going to switch over to video 1 second. Exact assembly. I will answer your question. I'm just going to go to me. Just rearranging everything. Pardon moi. Okay. So, to answer your question, so typically an FR4 piece with copper that is made in existing PCB houses, if one side is copper, another side is copper on pieces of FR4. And then they etch both sides, and then they etch another set, and then they squish them together and essentially plate the holes. And that's how you get a 4-layer, 8-layer, how many layers you want board. The way we're inkjetting is we're inkjetting conductive ink and then insulating. Conductive, insulating, conductive, insulating. By doing so, we don't have to do any drilling. So you can print openings, fill them with conductive ink, print a 2nd layer, 3rd layer, and so forth. To the point as the template, no, you can upload anything you want. But essentially, if with WYSIWYG, so whatever you give it, it will print. The drill file is kind of a critical part for connecting interlayers, so that's about that. There's no sort of template, you just go with it whatever you want. I'm not sure if that answers your question or not. During the input screen. Not sure what that means. Oh, you mean when you're uploading?
Yeah, that's probably during the upload process.
During the upload process. No, you just upload whatever you want. I mean, all we need from you for conductive ink is the drill file. If you're doing, let's say, drill files that are throughout every single layer, they're all in the same spot in the layer, you can just upload one drill file. You can upload multiple drill files depending on which part of the layer you're building through. Yeah, you can do all that. So blind and buried vias are possible. It costs us nothing extra. The input screen showed where the Gerbers are uploaded. It showed 2 templates. Yes, I did. I showed a single layer template, 2-layer template. The 4-layer template is incoming. Basically, to do 4 layers right now, you just simply do 2 layers, restart the print, upload the other 2 layers. That's about it. We want to have complete control where you upload all the different files in one go, and then we just integrate everything. So we're just doing some software work on that right now. But for now, you just simply upload the 2 layers twice. I'm not sure if it was answered your question. If you want, we can have a call later and explain it better, because it might be better over a call. So where are we at with the process? Okay, 6 minutes. Okay, so watching the curing process. Yeah, everything seems to be curing quite nicely. What's happening right now is the heat bed is heating up to 140 Celsius. It's going to stay there for about another 6 minutes, and then it's going to cool it down. There's a fan underneath, and that fan will generate airflow over the heat bed, and we can get it down to sort of reasonable temperature for the next step. And we go from there. Okay, what about the flatness? Can you fill in openings on an inner layer? Yes, you can. So when I'm printing an insulating layer, I'm printing everything but the drill holes, the quote-unquote drill holes, right? What I do is I fill that with conductive ink afterwards, so that we have to return to flatness. That essentially answers that question. Minimum line width? Minimum line width. I would say the minimum line width is 8 mils, 200 microns, and you can space it as much as 200 microns as well. Yeah, spacing would be, well, 200 microns as well. So pitch, pin to pin, is 400 microns, which is 16 mil. Via size, for example, I've gone up to 24 annular ring, down to 16 in terms of the size, 16 mil in terms of the diameter. Bigger vias are always better because you may have some offset ever so slight, and that's one thing you should probably watch out for. Smaller vias are definitely possible. I've definitely done small vias down to 24 or 16 in that range. Curing lines, we're looking pretty good. Show you the video. Oh, he does? Okay. Do you have any isotropy, vertical lines versus horizontal lines behave differently? That's a great question. So yes, that has been a challenge. So basically the motion of the print head has to be absolutely perpendicular to, the print head's like this. Imagine there's the x-axis, it moves across. It has to be basically perfectly perpendicular, because when you move down, do another large pass, you have to essentially make sure that the print head is not sort of angled, it has to be absolutely straight. We have seen some isotropy, and that's actually one of the limitations I find for doing thinner and thinner traces. But we've been continuously improving the mechanical stability of the whole machine, which is going to hopefully allow us in later versions to go even better, thinner, smaller, more reliable. Sorry, I couldn't hear the via and drill size. Yeah, so 16 to 24. I prefer to go higher than that if you can. Via size can be a bit tricky because you always want to get the maximum connectivity at the smallest possible size. I've done 16 mil diameter vias, but I like to go to like 20, 24 in that range. Did you hear that? Hopefully. Curing's almost done. By the way, this video is going to be on here forever, so if you have to leave, if you have to go out, I know we said you'd be done by 3, we may be done a little bit later. You can always pause, watch it later. Feel free. It's not a problem. It's always going to be here. We also have other webinars from earlier times, so feel free to see those too. Yes, any layer-to-layer resistance differences. Layer-to-layer resistance differences. I mean, I find that I get the best results, the highest possible conductivity on a single piece, single layer FR4. And that the slight bumpiness of the layers afterwards, the conductivity is not as high as it always is. I'd say there's probably like a 15% drop maybe. The vertical conductivity of the cured traces. The vertical conductivity, the vias. I never see an issue. No, I don't see any issues because the layers are so thin. I mean, an insulating layer is 200 microns. It's pretty thin. The vias are very, 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 let's say, low profile, which is one major advantage of this technology for that sort of getting very flat, very, very low profile prints. PCBs, that is. Okay. Based on what I'm seeing, I think curing is basically done. If you have any more questions, we will get to them. I'm just going to move on as quickly as I can because we only have so much time. So I'm just going to stop the print. I was only doing one pass, so cures pretty quickly. So there we go. We did cured. Move on to the next step. So I hit continue. Click next. The machine's going to ask me to remove the head. Remove the head. And then I'm going to pop the cartridge. And the way I pop the cartridge is I just take my two hands, open it like that. I pick up I always like, well, it's not that dried on there, so I think I'm okay. I always like to wipe it off. And if I can find the clip, place it in here. Put this in the fridge if you're not using it for a while. Otherwise, if you're using it for a few days, just you can leave it out, it's fine. Just keep it in its clip. If it's not in its clip, you just have to use more water to clean it out. It may impact your printing capabilities. That's just all I have to say about that. Now it's going to be asking me to attach the dispensing head. Okay, so I take my dispensing head, place it on here. Firmware is up to date. Okay, so I did not load the cartridge. Should have done it before I actually put that on. But here is the cartridge with the dispensing needle inserted in it. I'm not unloading. So I'm going to disengage. What I want to do here essentially is pull the plunger all the way up to the top. And once it's done that, remove the head. And this cartridge here has a syringe inside of it with a needle nose tip dispensing needle. I'm going to place that in here and rotate it and lock it in. The software kind of explains it right there. Click next. Okay, to load the cartridge, it's the exact what I just explained. Put the head on, wait for a second, and I'm going to hit engage. So right now, the head is basically plugging into the machine, and at a certain point, it's going to actually start dispensing. It's going to stick the plunger into the head. A little material is going to come out. And then it's going to essentially find the balance point. We want to make sure that the piece is under enough pressure that it's going to dispense, but not so much that it's over dispensing. Okay, so there you go. So it dispensed a little bit into the waste area. And what's happening right now is it's kind of returning to essentially a stage of equilibrium. I'm going to take a syringe here, or a Kimtech wipe here, and I'm going to do some alignment right now. I'm going to choose some very large pads. Oh, actually, you know what? It's not dispensing anymore, so I can probably choose a smaller pad. But I'm just going to, actually, I'm going to expand this. Can you see? Yeah, I'm going to expand this so you can see everything. So this is the align page. The align page is all about, if I had taken this board off, or I had an existing PCB board, and I wanted to dispense and assemble on it, I could just place it on here, align to 2 different pads, and the machine will know exactly how to orient to that said board. In this case, I already printed something earlier, so it's a little bit easier, but we want to make sure that everything's aligned perfectly so when it dispenses, it hits the pads and doesn't go anywhere else. So I'm just going to choose one pad over here, and essentially move over. Just taking a look here. Okay, there we go. There's one pad. And choose another one. Yeah, you can't. One second, just want to make sure I'm sharing the video here. 1 second. Pardonnez-moi. So right now I'm just aligning it, and I'm very close to the alignment I want. I want to move on to the sort of stage where we get a camera and this is all done automatically. This is kind of why our machine is sort of open platform. Less human intervention, the better the experience. But for now, we require a little bit of human interaction to make sure everything dispenses correctly. Okay, so let's get going. I always like to set lowest possible settings and then do a quick test parameter test. So you just put everything down to 0, and then I hit test parameter. Before I do that, I just want to ask if anyone has questions. Good, no one does. We'll move on to the next step and hit print. So it's going to clean the head with our fancy-dancy wiping system. 2 wipers like this. And then it's going to go over and dispense a long line. So this is kind of where our sensitivity in the system is really important. We're applying just enough force that, we hit the substrate, but not too much that it damages the very delicate dispensing needle tip. But essentially it places small Hershey's Kisses, and I'm trying very hard to get Hershey's to buy a few machines so they can make the world's smallest Hershey Kiss. I don't know, Troy, maybe we should make like a Guinness Book of World Records, like the world's smallest. Silly ideas like that, maybe get more attention than we need. Okay, so I'm looking at what I'm seeing. I'm pretty happy with the dispensing capabilities right there, so I'm going to hit next. And what's going to happen is just like before, you're going to see a start printing button, and the machine is going to go through the steps of cleaning, and then it's going to dispense. Everything is happening in terms of calculations, where it's going to go on the machine. Nothing is happening locally on your computer. Okay, dispensing quite nicely. I'm just gonna let that go for a bit and take questions right now. So, a few things about the dispensing you might like to know. The syringes are essentially open. You can fill them with any kind of paste you want. Like I have a syringe here. I think it's full of low temp solder. Um, Fill it with chocolate if you really want. Um, I find that the most important thing you need to do is to control the age of the the material. You want to keep it refrigerated, keep it warm when you're using it. If you're using pastes, try to thin them out so that you can have the lowest possible setting for dispensing. Otherwise, you're going to be extruding a lot more than you may need. Any more questions? Okay, good. You can use your own dispensing needle systems. Like in terms of lure locks, there's lots of different dispensing systems out there, like dispensing needles. We just have ones that are pretty small. I think I'm using the second smallest one we have, because I'm noticing now that the dots are pretty big for this guy. I think I may have swapped it out with the other one. But you can go down to pretty small. I think the smallest we use is 10 mil. Produces 12 mil size dots. I think I'm using the 15 here. But generally speaking, smaller you go, you may have like problems in terms of dispensing, or it's uneven. So we found that the settings we have work best with the 10 and 12 mil diameter needles. I have a question for users, if anyone's listening. Anyone here work with anyone work with flexible circuits, or anyone work with printed or inkjet printed systems on a larger scale, perhaps? You guys should contact me or let me know if you exist. I'd love to talk to you. I'm doing a survey on some new bonding techniques we have that work really well with flexible electronics. Pretty interesting stuff. Trying to get some market information about what kind of stuff you work with, especially if you work with like low temp or low cost substrates like PET or paper, because this is where I think this new bonding technique really shines. It also works really well for people working with very, very high density ICs on a general purpose scale. So we'd love to talk to you too. Yeah, just let me know if you're interested, because we might be able to share some information with you and learn a little bit more about what you guys are doing.
Jared works with Flex.
Oh, you do? Okay. Jared, do you have an email? I guess you've been talking to Jared. Who's you work with? What? Oh, okay, cool. Oh, excellent. Yeah, I'm going to follow up with you after this. Can't ask questions in the middle of a public forum on something we're working on internally for other reasons. By the way, please share whatever you're doing. I'm interested to know what you guys are doing, if you can share anything publicly. I know some people here are working with assembly systems. Some people are doing like actual prototyping. Um, got 9 people watching right now. Okay, he's already in touch. Excellent. Thank you. So we had a customer who was doing stenciling. He said on average, I think this is out of Mexico, on average it was like $500 for a stencil. And he basically bought a machine from us and he just replaced the stenciling process with dispensing. Really cool feature. All he really wanted to do was like, look, I got a source for boards, I have a source for assembly. I use the machine for assembly, but sometimes I just do hand assembly. Pasting was a great solution for him. He used his own materials, he sourced it and played with it, found a couple of batches that worked really well, and now he uses the machine solely for dispensing. That's kind of the cool thing about our product is that it's got a wide variety of uses. We find people trying to do stuff that aren't necessarily what we expected them to do. That's where flexible electronics, for example, we really didn't expect a lot of people to get big on that. But that's a huge expense for quite a few people. Making flexible electronics or doing something like that, unique or organic, is difficult to do because getting a flex board made can be cheap and expensive, but typically you're going to get failures you wouldn't even expect, like at bend points you don't expect, making sure that the compliance of the flexible material is good enough with the components. These are questions you wouldn't be able to easily solve if you had to wait 2 or 3 weeks for a board to be made. How do you align this machine with pre-made PCBs? Do you have to put fiducials on it? Yes, you can put fiducials on it, but you don't have to. I just used my pads as fiducials, which is maybe not the best idea because it might be a little bit of glue on the tip. So yeah, you can. There's a page, and I'm not sure if I showed you that part. Let me just flip over the video here for a second. And I will show you that shortly, Mr. Exact Assembly. Okay. Reordering stuff is difficult. Okay, so if you can see here, you can see my video, you can see the map here. I'm not sure if you missed this part, but basically what happens is on the previous page, I can't go back because I'll cause the machine to crash. Basically, I click on any of these pads, and I align to that pad, and I essentially set that. So if I had a board made, if I had, I don't know, some board randomly, I just placed it in whatever direction, I would just have to use my eyes to align the head to those 2 pads, and then the machine will align everything else, okay? Hopefully that answers your question. Material costs. Material costs of the paste is $200 for 3 syringes. 3 syringes has around 3 mils each. Actually, let me check that one. Sorry, 1.5. So it's about 3.5, 4 milliliters for $200. Yes, this is silver loaded material, so it's a bit expensive. But the overall result is, it takes a while for me to consume glue. So I would say that from a materials cost perspective, pasting isn't too bad. Your cost of FR4 and Kapton, you can find that yourself, but we sell a package of Kapton and FR4 with ink for about $700 with SV2. And I would say that you will run through about, let's think about this, 30 times 36, it's about 1,000 square inches. I think you'll run through all that with all the ink you have. I'm including, mistakes and screw-ups where you may kill your yield a little bit, but you can get upwards of 40 or 50 boards out of a set of materials that is around $100. I usually cost it around $1 to $2 per square inch per layer. Okay, we are nearly done. Okay. Someone ask another question? Oh, is it past 3? Okay. Oof. Sorry if I'm actually making anyone late. We're going to be getting to pick and place in about 2 minutes. And pick and place shouldn't take longer than 10, 15 minutes, so it shouldn't be too bad. What I can do is I can prepare myself for pick and place by doing a few small things. Pick and place, I'm going to be using, let's see, what am I showing here? So I have these component strips. These are SMT rails. And I have a standard issue pair of scissors. Back to school special. And what I'm going to be doing is I'll just be cutting small components off, or small strips off, and placing them on the rail. We want to get towards a process where you can just like upload a reel or something like that. For now, we're just sticking with the old system of taking strips, placing them on the machine, and just letting the machine do the pick and placing. So right now I'm removing the plastic on the components. Think what else we can do. So I have this component right here, so I'm going to pick and place this guy. Now I got to think about its zero rotation. So this is the thing. I need to actually look at the actual data. Okay, so I was just doing a little research looking at my design because I didn't know what the zero rotation of this component was. It's 0. So when I place this in the tray, I'm going to make sure it's aligned correctly. And this is kind of where I have to like think about design when I'm designing something. If I'm looking at a design I haven't made, like this one, I have to look at the data sheet to make sure I know what the zero rotation is. It's going to be rotated 0 degrees, so I can place it with the ground pin on the bottom left, because that's where ground is. I'll go over this again. I'm just sort of doing a little preparation. Looking at this is pretty good. I would say that it extruded quite a bit on some of the pads, and I don't like that. What I could do next time is I can make my pads smaller in the actual design so that it's going to extrude over a small area and I extrude less materials. Of course, if you're using solder-based or even glue, you can just wipe it off if it's too much. All right, so I'm going to go to the next step. Let's get the video, make sure I have everything. Okay, so. All right, hitting next. What's going to happen is the machine's going to ask me to detach the head. I'm going to take a syringe and clean it out. And we have this guy, which is, I think it's inventively called anti-hurt yourself device, because this is pretty damn sharp. Having this thing on is kind of nice. By the way, this machine is only for 18 and older. Sorry, your kid can't use it. Although I really want to get my nephew one. He's 10. He loves it. Yeah, sorry to any of the children on the website, on the video chat right now. Okay, so attach pick and place head. Okay, so pick and place head. By the way, if it says backwards, you put it on backwards. It's also impossible to put on backwards. The pins won't align. Machine is now thinking about it. Okay, head status brings up to date. So we're going to go to the next step. Align your board. Okay, so we're going to be aligning it to... see, this is where fiducials are useful. So you can use dispensing fiducials, and you can use like pick and place fiducials. So you don't have to align with a messy spot. In this case, I'm just going to align with this guy. I love tip exchange. It's so cool. Okay. So like before, by the way, Exchange Assembly LLC, if you're listening, you want to watch this page because this is exactly how we do the component alignment or board alignment for dispensing. It's the exact same process. The exception that I'm aligning to where the components should be, not where the pads are. But in this case, it's the same. I can just, you can basically see it as the same way. Okay, set alignment there. And then I'm going to pick another random spot. Okay, that's good. Okay, next. Ta-da, tip is replaced. Okay, so one thing that does confuse some people is exactly how to place components, how to use the interface. The blue instructions right here, I'm going to probably zoom up and make this larger. This kind of helps. If you want to place a component, you first have to choose a tray or a reel. We typically go with trays first because they're the most common components, and you want to do the last random components, the larger components that are in the tray. You want to do the trays first, which is on the left side. Typically, they might be the most difficult components, and then you want to do the reels, which are the smaller ones later. Let's try picking and placing the SOIC. So I'm going to pick up here, and the definition and explanation is kind of right here. We want it to be in a zero rotation. We want the component to be placed as if it was in the reel itself. So if you see here, a rail typically has your pins on the left, and your pin 1 or pin 0 rather is going to be on the bottom left corner. That is zero rotation in the system. In this case, the component is going to be placed in the tray in the exact same manner. It's going to be placed with the pin, bottom left corner, facing the bottom left side. So that's the zero rotation. And I checked my information, and apparently, yes, this is all correct. This is the way it should be, according to the center rotation file. Any questions from anyone? Hit us up. Okay, good. Moving on to the next step, you want to essentially click number 13, that's where the component's sitting, and click OK. Let's just pick and place the SOIC. Let's get this done. Okay, so I'm going to click place. Yeah, what's going to happen? Video over here. Is the camera on board is going to take a photograph, recognize that it has no tip, then it's going to go back to the pick and place. Oh, I realize now there's no section on the tip. This may not pick it up. Oh, it did. Excellent. So typically there is a suction cup on the larger tip, but in this case I don't see one. Oh. So rotation, if there's no suction cup, the whole thing is going to come offline. Ugh, that's brutal. My bad. I should have put a suction cup on that tip. There should have been one there. But no biggie. It's not needed for the smaller components. As I said before, and you may not have heard it, you want to make sure that the cup actually holds onto the component so that if you're moving, there's no vibration that will cause it to come off. And that component's quite large. There should have been a cup on there. No matter. We can move on to the next component sizes. So I'm going to go switch over to the 1206s, which are on the reels. So these guys are resistors. So I'm just going to select them. R1 is in a reel, and it's sitting in reel number 1. As you can see right here, I placed it right here and closed it up. So I select that one, and I pick and place some more components. You can do single, double, or triple. Basically, it depends on what kind of reel you get. Sometimes you have component reels where you have components every second instead of spaced very closely. They're a little further apart for whatever reason. These are all single spaced, so we're all good in that respect. Okay, so click place. I don't need a suction on this guy. It's small, not very important. There we go, not a problem. Does a little twirl. There. Moves over. Ooh. Oh, interesting. Okay. So it didn't recognize that component because there's some paper on the back of this, and it looks like my paper came off and the component went flat through. But the machine is going to know if it actually failed in picking up a component or not. And if you look here, it says, it says R4, you can place it again. So the truth is I can always basically try that again, and I've had to place more components. So the way I usually do this is if I have a failed component, I just pull it out, place it on the tray, and say, hey, can you do this one again? So we can do that right now. Take it here, place it on here. Let's see if I can get this guy aligned correctly. I don't like placing small components in the tray because I find, and this is kind of why I like the trays way more, or I like the reels way more. And in fact, you know what? I'm going to make it easier. I'm going to do it this way. I'm going to cut a few more, and we'll do a longer run. Is there any questions so far? No one's asking anything about different things? Okay, cool. All right, let's just get this ready. There. Oh, come on, get back in there. Wheel system's going to be a bit of an annoyance. Go. I didn't bring my component, my tweezers. I should have brought my tweezers. Of course, these scissors are magnetized, so I can't actually align everything properly. You know what? I'm going to get back to this later. I think right now we can just call it because we're near the end of this, so we're just going to move on to the closing steps. So I'm going to, if I'm done basically this run, I'm just going to go on to the next step. So I click next, and if it's unplaced parts, you basically say cancel to place them. But we're going to skip that and go to the next step. Okay, so ask me to attach the heads, and there you go. There's a heating profile right here, and the way it works is basically wait for this thing to heat up. Running. Click next. Okay. Huh. Did not ask me to heat reflow. Very unusual. Well, typically it should be, oh, it's curing right now. Okay, so we're going to wait for this thing to heat up and cure. So that's it. So we're going to wait for this thing to cure, and we'll go from there. I think this is the end of the whole thing. We're a little bit over time, so if you have any more questions, hit me or Troy up. You can contact us at contact@botfactory.co. We're going to be doing more of these as time goes on because we're doing getting a lot of requests to meet people, and we only have so much time to fly. So we're going to be doing more of these demos to demonstrate everything and take questions as we go, okay? And feel free to send us your stuff, send us your designs, whatever you can share. Love to learn what you're trying to make and see if we can help you make it with an SV2. All right, thank you very much, and have a great day.